Hello, geometry students. Mr. Zacek back and better than ever here with Unit 1, Lesson 8. And today we want to answer this question: what is a polygon and how are polygons classified? Okay, so I'm reading this definition that we have here of a polygon. A polygon is a two-dimensional closed figure formed by three or more segments. So three or more segments. Each segment is called a side. Each endpoint of a side is a vertex. So we have a few examples here of what is a polygon and what's not a polygon. So in this first one, a polygon, you see we've got the sides here. Give it a little highlighter. Okay, side, 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 and we have the vertex. Our second example here is not a polygon. It's not a closed figure. So see how A and E don't connect? That's open. And this one, the third one, is not a polygon because the two sides intersect between the endpoints. So that would not be a polygon. So very simply, to name a polygon, we're going to start with any vertex and list the vertices consecutively in a clockwise or counterclockwise direction. So the big point here is you don't want to zigzag when you start this. So we're going to look at this diagram over here on our right. Name the polygon two different ways. So we could call this D, H, K, M, G, B. So I started at D and I want this way. That's clockwise. Let's do one a different way. I'm going to start this one at G, and this time I'm going to go counterclockwise. So I'm going to go, whoops, no, let's go this way. Like that. So that would be G, M, K, H, D, B. All right, so you don't see it in this one, but one of the errors, one of the common errors that's probably happens more when we have a quadrilateral, okay, A, B, C, D, all right, this is not A, B, D, C. Okay, that's the wrong thing to do because, see, that's A, B, and then going like this, D, C. Okay, so we don't want to do that. We want to go clockwise or counterclockwise. All right, so let's identify the sides. I'm just going to go and just kind of use some different colors just to help us see the sides that we have here. Just to highlight them, give you a visual on it, and a little crazy crayon. Okay, so let's list those out. They're going to be segments. So we've got BD, DH, HK, and KM, and MG, and then our last segment would be GB. So there are 6 sides, and if there are 6 sides, we should have 6 angles, and so it would be angle B, angle D, angle H, angle K, angle M, angle G, and angle, already did angle B. Okay, so really simple, all the vertices are angles. Nothing too complex about that here. As we turn the page, polygons are classified by the number of sides. And so we want to think about what these are called, and so it'll be important for us to learn these as we go along. I'm going to make my pen a little smaller here. So a 3-sided polygon we call a triangle, tri for 3. 4-sided is a quadrilateral, 4 sides. A 5-sided polygon is a pentagon. A 6-sided is a hexagon. A 7-sided is a septagon. An 8-sided is an octagon. A 9-sided is a nonagon. A 10-sided is a decagon. Now, once you get above 10, with the exception of 12, we start using numbers. So this is like an 11 gon. That just means an 11-sided thing, and we could just like 11 gon, we would probably write it more like that. A 12-sided is a dodecagon. All right, and then an entagon is just, you know, an n-gon. So that could be 13, it could be 26, you know, you just write the number and then the number of sides, okay? So some other terms that we have, a diagonal is a segment that connects two non-consecutive vertices. So you see them drawn in here is in this picture, like R goes to D, that's a diagonal, but R goes to Y as well. So diagonals help us to understand if something is a convex polygon or a concave polygon. Convex, all the diagonals lie within the polygon. So you see this here in this example, all these diagonals. Again, a diagonal is it's a line that connects the two vertices that's not a side. Okay, so you can think of it in that way. And a concave polygon, sometimes with concave, what people think is a vertex is punched in. So that can help people understand concave. So if you look at like point G over here, that vertex, it almost looks like somebody sort of like punched it in, and that caved in, so concave, where it goes inside. But what happens in a concave polygon is this diagonal out here, PQ, which is not a side, that's a diagonal. It's connecting two non-consecutive vertices, but it's not a side. So I'll just erase that. So I don't want you to be confused in thinking it's a side. All right, and then so as an example, let's classify the polygon by its number of sides. So we look at this and we say 1, 2, 3. So I'm just looking at the vertices here to determine the sides. So 1, 2, 3, 4, 5, 6. So this would be a hexagon because it has 6 sides. All right, and determine whether this is a convex or a concave. Well, none of those points are caved in, meaning there's no diagonals that could kind of be drawn outside of it. And so therefore, this would be a convex polygon. All right, so there we go of the lesson, and you can look over those. The next page in your notes is actually what the assignment is going to be. So this page that's in our notes is the same thing that the assignment is. So we're not going to do this together, but this is some practice for you to work on helping you develop the understanding of the things that we've just talked about in the last 8 minutes. All right, good luck. Thanks for listening.